I'm now going to show you a CT VT valve. What does CT and VT actually stand for? Well, CT means constant temperature and VT means variable temperature. And we have the two component parts in my hand. In my left hand we have the valve body, and we'll talk more about that in a minute. And in my right hand I have the actuator, and the actuator is the device which is controlled by HeatingSave. So let's do away with the actuator for the moment. I'll put that behind me, and let's talk about the actual valve body itself. Now you'll see that this is what's called a 3-port valve. So what happens is the water from the hot water from the boiler, that comes through here, and then dependent on how this lever here is moved, don't forget, in reality this lever will be replaced by the actuator. So the lever can move in very, very small increments to either send the water from here through the top or out here, and it will do it proportionately. So let's have a look at the actual valve itself. So I shall now move it into the open position where the water comes in here, and if you look you can see right the way through the valve. So all of the hot water is being moved from here to this particular port. There is no water coming out of here, and if I turn this sideways you can see it's blocked. Now if I move now the valve to the opposite direction totally, you'll find now that the water comes in here. It can come out of the top vent or pipe, but has been blocked through the one that was previously open. So by moving this particular lever, and of course in the real world this will be the actuator we saw earlier on, at different points we can divert the water from the boiler through this particular port, through this top one back to the boiler. That is called a bypass. So we're just circulating that hot water back, and then we are proportionately allowing a certain amount of the hot water on the flow of the boiler to come out through this particular pipe. So now let's look at the actuator. And the actuator is the device that sits on top of the physical valve body, replacing that red lever we saw earlier. The actuator is controlled by one of two wires. If power is applied to one of the cables, and this is mains power, then the actuator moves in one direction, and if it's applied to the other cable, then the actuator moves in the opposite direction. HeatingSave does the clever bit by applying power to either this cable or to this cable to gradually move the valve in one direction or the other to maintain the temperature set point that has been set in the software. Now these actuators can be controlled either via two wires, which requires two relays within the HeatingSave system, or alternatively by a 0 to 10 volt supply, which also HeatingSave can provide. In both cases there's something called a PID algorithm which manages this, and later on we'll see that on the graphs of the software to see how well HeatingSave actually does the job.